So we saw how the formula works in Desmos. We weren't supposed to, but that was the best way to do it with the limitations that we have using graphing technology. So here we can see how the formula is actually applied. Now you may notice that this is different than the Desmos formula. In fact, let me open up the Desmos formula so you guys can see it right now. Oh, actually I can just click this button right here. So again, if you haven't seen the first video, I recommend watching that. I kind of go over this. Do not do standard form. I realized this later, but I did mention go to Conics and go to this. The reason why you want to do conics is this talks a lot more about the directrix and it focuses on the focus and things like that. So if you look at this, we see that we're dividing by 4p, and that's a little different than if we look at this formula. The reason being is, well, you divide by 4p, and then you add the k to get that y by itself, because this is y. So this is the formula we're going to be doing when we're talking about a directrix. So, and then horizontal, you're literally just switching the y and the k. And we saw that we did that in the first video. All I did was I changed this to an x, and then I changed this over here to a y. And we can see, oops, forgot to get rid of that y, or x, sorry. I'll change that to a y. And control 2, sorry. There we go. Sorry about that. Obviously, these points don't make any sense because I haven't changed this. This would have changed to y, this 0 on p, but that's the formula. So all you have to do is kind of change this up a little bit. You do have to change these because if you were to take the inverse of a parabola, that root, it doesn't look the same. So by doing this, you kind of create a non-function because it doesn't pass the vertical line test, but you do have a way to graph a horizontal parabola. And that, I think, is one of the huge benefits of having it in this format as opposed to standard format. So looking at this, we can see that the vertex and the focus are always that small number apart, that p number. So we can actually solve for the focus by knowing what our vertex is. Likewise, we can always solve for our directrix with the same thing. If we find the distance to a directrix, we can find the distance of the focus. And we can also convert a standard form parabola or even a vertex form parabola into this by simply just solving for p. So let's take a look here. So a vertex is right here. We have the axis of symmetry. So it's important to remember that the axis of symmetry of a point is always the x value of the vertex. So let's take a look at this formula right here. So this is the formula we've been dealing with a little bit. We have our h, our k, everything. So if we look at this, our vertex, let me grab my pen here. Oops, I didn't mean to touch my tablet when I did that. Our vertex would be 2, 3 because it's always the opposite of what's in these parentheses. Our p, so remember it's 4p. So in this case, 4p equals the 16 right here. So our p has to then be 4. So let's plug in our vertex. Our vertex would be 2, 3. So we're going to grab a 2, 3, plug it in for the vertex right there. If we're finding the h, that's the x value of the vertex. So that's going to be 2. Not x equals 2. X equals 2 is a line. So we're just going to plug in a 2. We're going to plug in our y, which in this case is a 3. So that's the k value. The k is the y value of our vertex. We need to find our p. Well, we already solved for p. That's 4. So we're just going to drag this 4, put it right there. Now it's like, well, what is our axis of symmetry? And the axis of symmetry should always be perpendicular to the directrix. So what we're going to do here is look at the x value. So we're going to say x equals. This is a line, so we do say x equals the axis of symmetry. And make sure you did this. I was about to stuff it on the focus. The focus point, there's a reason why they call it a point. It's a point. So what we're going to do here is, since this is a vertical parabola facing up, that means the focus is going to be, focus point is, we're adding P to the vertex. So in that case, it's 7. And we're going to have the same x value. So this is 2 comma 7. For the directrix, that's going to be a y equals, because this is a vertical parabola, so your directrix should be y equals something. And in order to do that, we have to subtract p from our y value. So in that case, we're going to get that -1. We already had some practice with this on the first video, but this is more official now since this is what they intended to teach us. And you can see all my check marks, so I got it right. All right, so let's talk about the formula. So vertical and horizontal. So if it's a vertical one, the way I like to think of vertical is these are the parabolas we're used to. If we're used to that parabola, a standard parabola, so in this case, what I mean by standard is your vertex is 0, 0. Your directrix is y equals -p, and your focus would be 0 comma p, kind of like that graph we did in the first video. So it's standard. That's what we're used to. We're used to vertical parabolas and everything. So if we're used to it, it should be a graphed in a way we're used to seeing, which is something like y equals. Well, if I take this formula and divide 4p from both sides, I get y equals x squared over 4p. If I wanted to, let's say, have it more of a standard form looking, it would be y equals x minus h quantity squared over 4p plus k. And one thing you'll notice too is the plus k, it's like, well, how come every time we graph, it's always plus k, but whenever we're graphing like an x, it's minus h. That's because normally it would have been y minus k equals all this right here. But when we move it over, that's when it looks a little different. And obviously the horizontal one, our x's and y's switch. So that's literally what we do. Our x's and y's are backwards. So everything's backwards. If this was x or this was y equals, then this is x equals. All right, so moving on. All right, so the focus and the directrix are always the same length. So the distance from the parabola to the focus is always the same distance as the point is to the directrix. And the way you take distance, you always take distance at a 90-degree angle. Now, why is it always at a 90-degree angle? Well, I've mentioned it a few times before in a lot of my videos. A squared plus b squared equals c squared. It's always how we're going to take distance. So this x2 minus y2, that's our a, not our a squared, just our a. And this y2 minus y1, that's our b. And this will give us the distance in between points. So it's always at a 90-degree angle. So I find it interesting that it mentions that this is a 90-degree angle, but it fails to mention that this is a 90-degree angle as well. All right, so this just shows how we derive it. This is really important. Normally I would explain it, but I don't want to like use words that might make this a little more confusing. But basically what they're doing here is a focus is always going to be assumed 0. So with that, they're plugging in all the rest of the values. So it's just a far away and then -a down here, plug in all the values, and we get this for AY. So that's where you're going to get that P. So instead of A, it's a P. So X squared equals 4PY. And then moving on from there, that's how we can start plugging things in for the horizontal vertex or horizontal parabola. And if we did it upside down, we're just going to be dealing with a negative value. So things we already knew, we're just going into further detail of it. The reason why we're starting with parabolas is in Algebra 2, we were very familiar with parabolas, so they're giving us something to work with. So once we get into conics and other things that we're deriving in calculus, where we're dealing with two variables that can each change. Before, we talked about how way back in algebra, things were a function was always something with an input and specifically one output. Well, sometimes when you're doing more complex things, it's never that simple. Sometimes you have a series of variables that give you a series of outputs. So we have to start getting used to there being another another variable that we don't see. In this case, we're talking about P. So conics is kind of a good way to kind of start getting into that. Let's see here. So again, this is explaining a lot more what I did when we did the activity, but it's just showing how we can solve for the directrix and everything. Watch the first video to get into more detail. Read this if you want to see how Edmentum explains it. I'm always the type that says having a different perspective is always really good. All right, so if we're looking at this, this is another way of saying that. So let's say we wanted to find out where our focus is. We have this formula and it's like, well, where's our directrix? Well, if this is a horizontal parabola and this is y squared equals negative 12x, we know that our formula is normally y minus k squared equals 4p times x minus h. Well, since we're at 0, 0, we know that we don't have, or 0, 0 for the vertex, we know we don't have an h, we don't have a k. So that means that y squared equals 4px. Well, now we have a y squared formula and a y squared formula. So this is where I said you just set them equal to each other with another formula and you can solve for it. So we have negative 12. I'm sure some of you already figured out the answer is negative 3, but we have negative 12x equals 4p x. Our x's would cancel out because they're on the same side. So therefore, our p is negative 3. And because our p is negative 3 and that gets added, this would get added to the vertex, our focus would be here, and this would be subtracted from the vertex, which means our directrix would be right here. So that's how you can find a focus and a directrix given a specific formula in a different notation. All right, so let's go on. All right, here. So given this equation, what is the value of the directrix? I don't know why they're using A instead of P. So if you're coming from the second video, which at this point you're like, let me go watch that second video because this guy keeps mentioning the first video. I use P because that's literally what everyone else in the world uses. Edmentum is special in more ways than one. So they're using an A. All right. So what I'm going to do here is, since I'm using an x squared, we're just going to do the formula. So you don't have to write it down every single time. After a while, you'll get used to it. X squared equals 4p y k. So seeing as how there's not a k, we're going to assume that sorry, we're going to assume that the vertex of this is in uh, as at the origin. So we can just say it's x squared equals 4py. So that means we're just going to divide that 8 by 4 and we're going to get a 2. All right. So let me clear this out. And that's all we're pretty much doing when we're given a formula. So we have this formula. Well, this one's asking, where does the vertex go given where the parabola lies? Well, because again, we don't have any like minus k or anything, that's why we're assuming it's going to be at the origin. So I'm just going to say it's at the origin, 0, comma 0, comma 0. Hopefully, Edmentum doesn't care that I put a space in between there. Oh, and it doesn't. Sweet. So yeah, the vertex is at the origin. All right. So where does the directrix lie? All right. So this is a, and if you're having trouble identifying it, just remember whenever we dealt with problems before, we always had an x squared somewhere in it. It was always a quadratic. Quadratic coming from the Latin quad, which means square. So there was always a square on the x. So we know that this is a vertical parabola. We know because it's positive, it's happy. It's a positive parabola that's facing up. So that means that directrix is going to be below this vertex. So our directrix, sorry, because it's asking for directrix, is going to be negative p, or in other words, subtract p from the vertex. So we need to subtract p from the vertex. We said that uh, the vert that the vert ah we said that p was 2. So we're going to have 0 for the x because the x value of, oh wait, no, it's a line. Sorry. This is a y value because all the y values are the same. So we're going to say y equals negative 2. We're subtracting 2 from the y value of the vertex, and that gives us the line for our directrix. So let's put that in there. Perfect. All right. Edmentum has done some special things, but nothing for me to get mad at yet. All right, so let's take a look here. So I'm assuming now it's going to ask for the focus. Yep, it's asking for the focus. And the focus, we're always going to add. Focus, first of all, is a point. And we're going to leave the x the same because it's a vertical parabola, so there shouldn't be a shift in the x value. You're not going to have a parabola where it's like, here's the parabola, over here's the focus. It's going to have the exact same x value. So we're going to add x to, or we're going to add p, I'm sorry, we're going to add p to our y value. So x stays the same. And our p is going to be that plus 2. So since it was at the origin, we're just adding 2 to that 0. Perfect. And I'm assuming the next one is the axis of symmetry. Oh, it didn't talk about the axis of symmetry. Oh, well. So here's the formula for how to substitute. Now we're going to do it with horizontal parabolas. So if you watched the first video, you saw that it was a struggle kind of explain to you how to graph this because first of all we didn't have the tools and I had to explain all of these from scratch. So hopefully this is starting to make a lot more sense now. All right, so let's get into this. So now we're talking about the equations of the parabola. All right, so let's get through this part. This shouldn't be too bad. So find the equation for a parabola origin whose focus is this. So we're saying that we have a parabola who's at the origin, so 0, 0, and the focus is 0, -2. So the focus is down here. So first of all, that means that we have a negative p. our p is negative because our parabola is negative. All right, so right off the bat, we know this is x squared because it would let's look at the formula. I realize I'm going a little too fast here. I'm sorry, especially since you guys can't comment until after I film this. X minus h quantity squared equals 4p y minus k. Now, because we know it's at the origin, we know it's going to be x squared equals 4pk. Reason being is there is no, or k, y. I'm so sorry, guys. I'm only human. um, so y. All right. So if we do this, what's going to happen here is there is no k, there's no h because we're at the origin. So we need to figure out what this p is. And the p is always the distance between the focus and this. Because it is a -2, that means this p has to be -2. So the answer to this question is x squared. Oh, you know what? You have to use the equation editor for this. There's kind of no way around it because there's no way to do that squared. Um, if you guys are watching this in the pre-calc class, I don't like seeing those little arrows. Use the equation editor. There's no reason to use the arrows when we have this perfectly good tool here. So x squared equals, well, what's p times 4? Well, our p is -2, we said. So that means we're going to have -8y. Then we can submit that. You can see our formula right there. Perfect. They plugged it in and solved it. That's actually a better idea than what I did. um, so let's solve this next one. So now it's giving us the directrix. Now keep in mind that the directrix is always minus. So if it's at the origin and we have to subtract our p from the x value, because in this case, we're talking about if we're subtracting it from the x value, first of all, if the directrix is x equal, this tells us that we're dealing with a horizontal parabola. So because we're dealing with a directrix that's x equals will be a vertical directrix, means we're dealing with a horizontal parabola. Ergo, we have to use the formula y minus k quantity squared equals x, or not at the x minus h part yet. I'm getting ahead of myself. 4p times x minus h in parentheses. All right. So our p, if it's already give me a second here. If it's already 3, and we know that's going to be subtracted, then we know that our p, so x minus p equals 3, and we know that our x, it comes from this origin. Or I should say, you know what? I shouldn't say x minus p. I should say h minus p. H minus p gives us 3, and our h is 0 minus p equals 3. That means our p equals -3. So p equals -3. And this is 0, this is 0. So we're going to have -3 times p. So we're going to get this y. Oops. And again, use the equation editor. We're going to get this y squared equals -3. Oh, you know what? I'm going to plug it in. 4 -3 x. And technically, if I wanted to get more technical, I should be doing it as y minus 0, control up. I hate that it's control up instead of shift 6. Which I'm sure it's like, why is that? But if you guys see my videos, you've seen I've complained about this enough times. So we're going to do that. So that's our formula. And we're going to plug in the 0. And we're going to plug in the negative 3. 3. So I guess that's enough to say this is negative 12. There we go. I don't know why they're not plugging in the 0. Oh, they're probably doing it because they want to teach you how to do this with just the origin first. Now we're going to find one. It's an origin and passing through. All right, this is something we haven't done before. This is our x and y. This is why I had to correct myself when I was talking about, oh, I shouldn't call it x and y. I should call it h and k, because h and k refers to specifically the vertex. X and y are any random points that's passing through. In this case, this was passing through. So, um, one important thing to note as well here is it tells us that the parabola, find a parabola with a vertical axis. So this is a vertical parabola. I've been calling it vertical parabolas, but technically it's not a vertical parabola. It's a you get the idea. It's not a vertical parabola. It just has a vertical axis. But if the axis is vertical, you might as well just say the parabola is vertical. That's my opinion on the matter. Anyways, so if it's a vertical parabola, these are the ones we're used to. So we know that it is x minus h quantity squared, because x's are squared in the parabolas we're used to. 4py minus k. And when we're doing this, we're going to plug in our vertex, which our vertex is the origin. So it's x squared equals 4py. We have no idea what y is, but now we have an x and a y to plug in. We had no idea what p is, I'm sorry. But now we have an x and y to plug in, so we get this negative 2 quantity squared equal. When I say quantity squared, I mean the negative, the thing I said before it, is also being squared. 4p3. So we're going to get positive 4, 12p. So this is going to end up giving us it's going to give us a p that's a fraction. And that fraction is 1/3. So our p is 1/3. So let's graph this out. Again, it is the origin. So what we're going to do here, we're going to say that negative 2 quantity squared equals 4 p y minus 0. Y minus 0. 3 minus 0. Negative 2 quantity squared equals 4 3p. 4 equals 12p. P equals 4/12, which is equal to 1/3. Ergo, our formula is x control up squared. No, what happened? Ergo, our formula is x control up squared equals 4 times 1/3 is 4/3 y. And they put 4y over 3. Same difference. All right, so let's move on here. We got one left. And I'll finish this video after I'm done solving this one. Identify the vertex, focus, and director. Ooh, we have to do everything on this one. Well, first of all, this is a y squared. So we know that this is a horizontal um is a horizontal parabola because it's because of the y squared. So that being said, we have the formula y squared equals and it doesn't say it, but I'm gonna assume it. Um, you kind of need one of these to be stated. So right off the bat, I'm just gonna say my vertex is 0, comma 0. Again, they don't say it, but because of the fact that there's no limitations, there's no plus here, so we know there's not a k somewhere random. The h, we're just gonna assume there. Again, since there's nothing here, there's nothing being added. We can't really say there's an h, otherwise that 2 would have been multiplied by that. So there's no h, there's no k. So we're going to say the vertex is 0, 0. We're going to say that 4p has to equal 2. Ergo, p is equal to 0.5. This is literally because I'm too lazy to do the fraction button on, you know what, I'm just going to do it. I'm like, there's no reason to be that lazy. P equals 1/2. Perfect. So P is equal to 1/2. All right. So that's our vertex was really obvious. There was nothing that's being added. So we know it's 0, 0. In order to make this equal to each other, this 2 has to be equal to 4p. There would be more work if our vertex wasn't that. So the focus is always we add the p. So we're going to write here, because we're dealing with fractions, unfortunately we have to use the equation editor. Focus is, we're going to add, because it is a horizontal parabola, we're adding it to the y value instead of the x value. So in this case, oh wait, no, we're adding it to the x value instead of the y value. Normally, when it's a vertical parabola, we would add it to the y value. In this case, because it's horizontal, we add it to the x value. And you can think about it logically. If your parabola's like this, your x value is changing when you do the focus. So this is going to be, I had it right in my head. I just said it out loud, and I apologize for that. So because it's horizontal, we're adding it to the x value. All right. And our directrix, if it bugs you, like it does kind of bug me sometimes, that the parentheses aren't getting bigger with fractions, use their parentheses. And if you do that, they actually enlarge when you're using a fraction. And then the directrix, directrix is, the directrix is a line. In this case, because of the fact that it is a vertical line, because our parabola is horizontal, we're going to say that x equals 1/2. We can see that the change is always going to be there. However, we have to subtract the 1/2. So it's negative 1/2. And then we'll submit that. I believe that was everything. I don't think they asked for the formula. There we go. So here's this. So remember, you always add p to the corresponding x or y value, depending if it's horizontal or vertical. And then you're going to subtract p from the vertex in order to get this. All right. So here, just write down what you think is best. I used to give examples, but I think hopefully you guys understand how to do a self-evaluation. The score doesn't matter so much as reflect. This is a time for personal reflection. All right. So hopefully I'll be able to knock this out in the next video. I know it's going to be like, what, 18 more slides, but I hope now that we've gotten through the harder parts, this will be easier. All right, guys, I will see you in the next video.